this workshop is mainly for people who are new to programming and don't really have too much of a background in it. And if that's you, this workshop would be great. But if you already have some knowledge in Python and also other programming language, so if you know what a for loop is or a while loop, then this works. Wait, if you know all of that, then this workshop may not be super beneficial to you. And we would encourage that you work on your projects instead. All right, so with that said, I'll get started. Okay, so the first kind of fundamental thing we have to talk about are just variables and data types. These are kind of like the building blocks of programming, and we'll also cover simple little functions. We'll talk more about those later, called print and input. So we'll describe what all of those mean and what a function is very shortly. Yep. So like we mentioned previously, we're going to use Google Colabs and repl.it. Feel free to code alongside us as well. So you can open up your own repl.it. You should have a hacker plan, given that you're an Explore Hacks participant. And yeah, just feel free to test out anything that we're using. We're also going to give out the repl.it that we'll be using to code after the workshop as well. Okay, so getting straight into things, variables in Python, or really any programming language, are just like the same things as you would learn in math. So as you can see here, we have x plus 3. And when you see that in mathematics, you know that x can be really anything. And the same, you can do a very similar thing in Python. You can define a variable to be some value that you want. So if I wanted to have some variable called x to be analogous to the math example, and we want to set it equal to some value, which we'll say 2, we can just type this into our Python terminal, and then we'll have a variable whose value is equal to 2. And we can always use this variable later, and then we can run this line of code, let's say x plus 3, and we wanted to store this in another variable, let's say y. Then all of a sudden, y is going to be equal to whatever value x was plus 3. But since we initialized x to be 2 up here, similarly to like in math, if you were to pretend some variable was some number, y will be equal to 5. So David, if you could show what that would look like if we run it in code.
Let's go to the REPL. Oh, wait.
I can share my thing if you want.
Oh, yeah. While I set this up.
Okay, it's going to stop your sharing though.
Yeah.
Okay, so apologies, but as we showed earlier, we can define a variable like this. We can just say something like x is equal to, I think I said what, 2? And then if x is equal to 2, then I can just run some expressions. So I'll say maybe something like why can't I type? Yeah, let's say y is equal to x plus 3, I believe. Then once again, I have a variable called x, which now has a value of 2. And now y, which is a variable with the value of x plus 3, which is 2 plus 3, which is 5. And if we want to display what this is, there's a nice function in Python for us to use. I'll explain what functions are later. But for now, you can just think of functions kind of like something you can use. So you can think of it kind of like a tool that you made to reuse. So for the sake of this example, print is like a tool you can use to just print out whatever value you want. So if I run this, okay, we should see 5. And the reason why this intuitively makes sense is because, once again, y was equal to 5 due to the fact that x was 2. And if I just wanted to print out that value, then I could just pass in my variable name, which was y, and then I would see 5 up here in the console. And that's really the concept of a print statement. And if I wanted to just print out y, I could wrap this into little quotation mark things and turn it into a string. We'll talk a little bit more about what that means in the coming slides, but just know that typing print with quotation marks around your variable name and typing print without the quotation marks is completely different. So if I run this, you'll see I'll get y on top here, and I'll get the variable value, which was 5, below. And also just one thing I want to clarify. If you pass in some variable name that doesn't exist, so let's say I wanted to pass in like, I don't know, David as my, I can type David as my variable name. You'll see there's this little red underline down here, and that's to show that there's an undefined name called David. And that happens because I don't have anything called David in my code. Python's going to look through what I have here and look for something called David, but that doesn't exist. The reason why this works was because there was something defined up here. So if I were to run David equals hi, this is a string. Once again, I'll explain what that means more later. If I run that, then you'll see that I get hi below. Yeah, and that works. Okay, I see a quick question here in the chat. Python, it's actually used for a whole host of tasks. It's one of like the most powerful languages in my opinion. But once you really get the fundamentals down, you can use Python for anything from web development backend, so that's like handling your databases, all the way to things like machine learning. Like Python's really famous for machine learning, and I think you can even make games and stuff as well. So it's a really useful language.
It's also just a good starting language just to get all the like concepts in coding for when you move on to other languages.
Yep, absolutely. All right, so I'll let David share again. Also, David, could you share both your repl.it and the slideshow side by side? Okay, yeah, great. All right, so we kind of just covered the concept of a variable, and one thing that I really wanted to emphasize is just when you create a variable, like as you saw earlier, we had X, Y, and David. There are certain conventions that you should always follow when you create variable names. Like for example, when I was creating the Easter egg for our website, if you haven't found it, you should go and find it because we coded an Easter egg into our website. But when I was coding that Easter egg, I had probably a good like 50 variables there. And if you don't name them correctly, it becomes really, really difficult to find. And an example is I had to have some variable to store the radius of a circle. And what I had was I had two variables. I had one named r and one named radius. And that became really hard for me to figure out which one was which and which one I needed to use. So there are certain conventions that you need to follow when you create variable names. Like obviously you don't want a bunch of like numbers at the end of your variable names, which makes it difficult. And there are two conventions. The first one is called camel case, which is like you have a lowercase word in the front, and then the other ones are uppercase. And you can also have one with underscores, and that's called snake case. And once again, Python doesn't get angry at you if you don't do this. It's just really for you to keep track of.
Yeah, and this is just like for naming variables, naming functions, that type of stuff.
Yeah. And as a fun fact, snake cases are used pretty widely in machine learning, just as a convention. Okay, so as promised, now I'm going to get to stuff like data types. And I was started talking a little bit about strings earlier, and they're going to come in, I think, later. But really, the first most basic data type that you can have in programming is what's called an integer. And the best way to think about it is, once again, just look at the mathematics side again. An integer is just any whole number, and you can see the examples here. They're just really any whole number, and if you store like some variable, let's say x again, if we store x equal to 2, we can say that the data type of this 2 and also x is an integer. And that should make sense because this is a whole number. So just this is one of the most common data types that you'll run into. Going back to that radius example that I used in my Easter egg, that was also an integer. Like I didn't have a decimal point radius, I just had a integer value, and that was why that's an integer. Okay, and then the next data type, David. Okay, the next data type is a float. And I think in the chat, somebody already put like an example of one. So I'll just use his example. I believe that's pi, by the way. But a float variable, no, not float variable, a float data type is basically just a data type that handles decimal point numbers. Earlier, integers handled whole numbers, but floating point data types handle decimal numbers. And what you can do is you can store x equal to that value that Steven put in, just like 3.14. I did not write that correctly, not 3.1.4. 3.14 and then so on, like the digits of pi. That's a great example of a floating point number. All right. And then, all right, moving on, I think. Okay, yeah, and there are also other data types for complex numbers and imaginary numbers, but we don't need to worry about that here. I think there are libraries that handle that for you, and it's beyond the scope of this workshop. Okay, and then this was the strings that I was talking about earlier, and a string is basically just comprised of a group of ASCII characters. So what's most beneficial for me to remember strings is just to remember that they have little quotation marks around them, and also little what's it called, apostrophes here. And basically anything inside here, let me change that color. Anything inside here between these are it's a string. And as David mentioned, I mean on the slide, sorry, they're just groups of ASCII characters and they can be combined into words. So for example, this is a string with the value of hello. Basically, going back to this, just anything surrounded in these are a string, and then you can store them into variables. I could do something like x is equal to hello, and then reference that value later, and also print it out like I showed before. And chars, chars are just an example of singular strings. So if you just have a letter there, and you don't have multiple letters in there, like if you have multiple letters, that would be a string. If you just have one, this would be called a char, short for character. Yep. So these are just a list of a couple really like fundamental data types that you'll encounter pretty much for the rest of your life if you decide to do programming. Oh yeah, I forgot one, but this type of data type is called a Boolean, and these are absolutely fundamental to things like machine learning and actually almost every application. But the best way to think about Booleans is just to ask yourself whether or not something is true or false. And then this type of data type can store that information for you. So in Python, if you want to check if two things are equal, you can write two equal signs next to each other. And then what you would do is ask Python whether or not the thing on the left would be equal to the thing on the right. And then if you were to just ask someone, I don't know, down the street, and you were to ask him if 2 is equal to 2, then he might say, yeah, that's true. And that's basically what a Boolean is. You're asking Python whether or not these two things are true. And if it is, this will output a true for you. And if they're not, it'll output a false. And then these two values are kind of the binary things that can be stored inside a Boolean data type. So what you could do is, going back to our example of x, you could set x equal to true, or I don't know, y equal to false. And then you could use these two values later. Because let's say x stored whether or not 2 is equal to 2. If 2 is equal to 2 and you wanted to store that somewhere, then you could just store that in this x variable and have it equal to true and assign it that way, and then reuse that value later in multiple if statements, which I think David will get to later.
Yeah.
Yep.
Also, I don't think we go over here, but not equals is just exclamation mark and an equal sign.
Yeah. Not equals is kind of like the name states. If you want to check if one is not equal, oh, no, not that. You want to check whether or not one is not equal to two, then I think this is right. You can do this in Python, and then this would allow you to, I mean, this would output a true if you were to store that into a variable. Like if I wanted to say x was equal to whatever this is, since one is obviously not equal to two, then x would all of a sudden be equal to true. Like if I were to replace this exclamation mark with just another equal sign, then x would be false.
Mm-hmm.
All right. Also, feel free to ask any questions in the chat or speak up. You're never interrupting me, and your questions are always welcome.
Yeah.
Yeah. So for the code along, thing is, we'll open up our repl.it shortly between slides, and then we'll go through kind of the stuff that we talked about. But so far, all the stuff that I've been writing on the screen has been valid code that you can always pop into your terminal. I mean, into your repl.it. Okay, data types, converting between them. I think this would be a good time to open up the repl.it. Okay, so earlier you just kind of heard of a couple of the really common data types that you would always, that you'll pretty much use for the rest of your lives. And there is one thing that is really important though. Sometimes you're going to need to convert between the different data types. Like let's say I wanted to have, I don't know, let's say I wanted the variable x again, and I wanted it, let's say it was equal to 1. Let's just say that. And then I also said, actually, hold on, let me reassign this. Let's say x was equal to hello.
You can actually just type this if it's easier.
That is true. That is true. Yeah, 1 second. All right. Let's say x was equal to hello. So all of a sudden it's a string. I'm actually going to rename this because x isn't really descriptive and it doesn't tell me anything. So I'll rename this to greeting. I'll say greeting is equal to hello. And then let's say I wanted to have some number, which was, I don't know, let's say 10. And I wanted to print out a message to whoever was looking at this program and say whatever my greeting was to this number. Doesn't really make sense to greet a number, but we'll roll with it. But the syntax you would use, syntax is just a fancy word for just what Python can understand. So what Python understands and expects. So the syntax that you would use to print out both the greeting and also the number that you're greeting to would be something like this. Greeting plus string. Also, I'm going to put a space in between here, and I'll explain exactly what this line of code is doing, because it may look a little bit foreign right now, but we'll clear that up. Okay, so this is actually a good opportunity to introduce a concept called concatenation. And it's a really long, but it's a really long word, but the concept of it is quite simple. Essentially what you're doing is you're just smushing two strings together. Python allows you to add one string to another and then smush them together and turn them into one big string to use later. So if we were to do greeting, which was equal to hello, plus the space in the middle, then what this is equal to is just hello with a space at the end. So then that would be the output string. And once again, this is called concatenation. But like I said earlier, since I want to say hello to a number, I can't add an integer value here. It doesn't make sense to add a string, which is a different data type, to an integer, a whole number. So what do I do? Well, to solve that problem, what I have to do is convert my number into a string so that I can concatenate them together and say hello, and then whatever my integer value was here. So it would be hello 10. So it would actually end up looking something like this. And that's what this string function does for you. I'll talk more about functions again later. But whatever you pass into this string function, which is inside these little parenthesis things, is what's called a parameter. And whatever value is passed in, Python will convert into a string for you using the string function, and then you can add all these together. So let's see what happens when I actually run it. If I run it, you see that's exactly what we wanted. We see hello and then 10. And just to show why it's necessary to convert between data types, if I run this code with number being 10 and not a string, we'll see an error which says you can only concatenate string, not integer, to a string, which is why it was necessary for us to use that function earlier to convert it into a string and then concatenate it again. All right, so that's a good example of type casting, or like changing between types. All right. Oh yeah, you can also do the same thing for floating point numbers, so float data types and also integers. And if at any point, let's say you had some really, really complicated logic and you were changing your variables like in 5 different places, then sometimes you might not know for certain what the data type of that variable is in a particular instance. And sometimes you really do want to know what it is. So what you can do is you can use this type function, which is, once again, I'll talk about more of that later. But you can pass in your variable here into this type function, and what it'll give you, or what it'll return, is whatever data type it is. So here you can see it's an integer. In the middle, you can see that it's a float. And at the very end, you can see that it's a string, because here I'm converting into a string. Okay, I think we already covered this a little bit here. Yeah.
It's just, when you print, all the values have to be strings.
Oh, okay. Here,
Oh yeah, so you're converting y into a string version of y, and y is 2 in this case. So that means y will still be 2, but it'll be as a string. And when you add these numbers, since y is 2 but as a string, it gives you an error.
yep. So you have to make sure that all of your data types match up and that they're compatible with each other. Like here, we've just been using addition so far, but Python also supports things like multiplication, division, and other operators like that. You can feel free to look them up on Google, but multiplication and division are kind of self-explanatory. Multiplication is denoted by an asterisk, and division is denoted by a divide, like a, what is that, forward slash.
And that's another thing to remember. So you can't add strings and integers together, but you can add integers and floats together. Those are compatible.
So that's a good question. Could you go back one slide, David?
Mhm.
Yeah. So yeah, y began as an integer up here. So that's a good point. Y was equal to 2. But if you go down here and you see us doing y equal to string y, what we're doing is we're reassigning the value of y. So here it's initially equal to 2. But once we come down here, y is going to be equal to the string value of whatever it was before. So then y is now equal to the string 2 and no longer the integer 2. Does that make sense?
Yeah, we can also show this real quick on the REPL.
Oh yeah, we could show it. So I think type returns things. So if I were to print type of y up here and print the type of y down here, then since we're converting between these two, you should see a difference. So if I run this, we'll see up here, this is the first print statement that comes up. You see it's an integer, but after that we convert it into a string. And that's what we see here. And
Yeah.
the reason why that addition from the previous slide didn't work is because this y simply turned into a string. And also just one thing that you should note, you don't necessarily have to reassign this to some value of y that it was before. Like I could reassign this to whatever I wanted. Like, I don't know, I could say, I don't know what's on my mind. Deviled eggs. I had a couple of those later. I think I spelled that right. I could reassign it to deviled eggs if I wanted. And if I print, then we'll have 2 from earlier because this was the initial value of it. But since I reassign it to deviled eggs, then if I print it again, that's exactly what we see on the bottom here. All right, so back to slides. Okay, another data type. Personally, I actually know it is a data type, but a list is, the best way to think about it is it's a data type to hold other values. That's the best way to think about it. And the name list is kind of self-explanatory, and it's denoted by these little square brackets here. And then the actual values themselves in here, separated by a comma. And lists are super, super, super useful in machine learning because imagine you have to store, all the data that you're going to use to actually make a model. You can store all of those values in a list, or if you want to look more into it, you can store them in what are called NumPy arrays. If you don't know what this is, don't worry about it. But these are just basically a special list that allows you to store values more efficiently. You don't need to worry too much about this. It's just to understand the concept of lists and why they're really useful, just to store data for you. So I'm not going to pull this up in repl.it because we have a little example here. But as you can see here, we're assigning our variable thing equal to this list here. And if we print it out, then it would make sense that we get exactly what we entered, right? And that's exactly what you see down here with this 1204 list. And down here, we're calling. So I'll define what calling means in a second. We're calling this function called append, or rather it's called a method. Method and function are basically almost the same. So you can think about them as the same way. And remember, like I said earlier, for now you can just think of a function that does something for you. So calling just means to use a function. So if I call this append function, what it does for me is it just adds this value apple to the end of my thing list here. So if I print it out again, you see we have apple at the end. So just to recap what happened there, if we call a function called append, it adds the value in here, which is called the parameter, whatever's passed into the function, and it adds that to the end of our array because of how this append function is defined. Okay. And that's probably one of the most popular functions that you'll use in Python for lists. Just one note though, you don't really have to memorize like all of the different types of methods that are for lists and other data types. Like there are a lot of them, and to this day I don't know all of them, and that's why you have to use Google a lot. Google's probably going to be your best friend when you're just starting off with programming, and you're always free to look up the functions when you need them. So an example would be like if you wanted to say remove an element from a list instead of adding, then you could just look up what that is in Python and then use it directly in your code.
And also, an important thing to notice, it's just like in coding in general, and in this case in list, you start at index 0. So it goes 0, 1, 2, 3, 4. So it's not like, it's like if you want to access it like here, it's thing and then 0, which accesses the first item in the list.
Yeah, so just going a little bit deeper on what David said, you have this array here. like arrays are great, not array. If you hear me say array throughout the rest of the presentation, just know I mean list. They're kind of analogous. But if I have the thing list here, then, if I just want to use it to store my data, what good is it if I can't really grab individual values, right? That's not very great. And if I want to do that, Python has something called not string, but list indexing. This actually, whatever I say here is also going to apply to strings, but I can have indexes. 1, 2, 3, 4. And what this means is if I want to grab this first element of my list, what I can do is type thing 0 with these brackets. And what I'll do is I'll tell Python to go into my list and grab the element at my 0th index and then put it out here. So as you can see here, if I print that out, I get 1 because this was the value in the list. And the same thing for print thing 4. Here, I just tell Python again, all right, go to the 4th index, grab the value, and then give it back to me. One important thing to note here is that if you did something like thing at index, I don't know, 1,000, you'll get an error because there is no 1,000th element here in my list. So Python will give you an error if you try and go out of bounds. Okay, dictionaries. Wow. All right. So this is another type of data type that you'll probably come across a lot. And once again, these are also pretty useful for, I think, yeah, they're really useful if you use JavaScript to create what are called JavaScript objects. JavaScript objects are the same thing as Python dictionaries. And if you want to store your data, dictionaries are a great way to do it. And although the syntax may look a little bit intimidating at first, I'll break it down really quickly. So to create a dictionary, you just need these little curly braces here in the front and in the end. And then we'll have some key here, like 1, 2, and 3, with a colon and then a value next to it. So that just kind of breaks down what it is. But then to show what it does, it's just kind of like if I wanted to grab a value from my dictionary. So just keep the definition of a dictionary in the back of your mind. When I wanted to grab the value of it, let's say I wanted, let's say my books 1. If I have my books here, which is a dictionary, and I want to see what value is mapped to 1, I can call it like this. So this is kind of similar to the list syntax we had earlier, and this will give me a cat. So to go back to that definition of a dictionary, the thing here on the left is like the word you're looking for in a dictionary. So here we'll say it's 1. And then the thing on the right is just the value you want to get out, which would be something like the definition of the word. So here I'm basically saying, all right, give me whatever value 1 is mapped to, which is this key. And since the thing on the right of the colon is a cat, this is exactly what it'll give me. So I can try this out in the code. David, do you mind coding this example?
Yeah, sure.
Yeah. Also, since you may see us like deleting the code here, we're actually going to go back to the history of our REPL, and then we'll add it all back later, and then share the REPL with you all through Discord announcements.
Yeah. So if we have like my dictionary equals, and also one thing to remember for syntax, so list use square brackets, and then dictionaries use squiggly brackets. So if we have like the index as like 1, and then we put a string here, like let's just put the word. Also, you separate these with a colon, and then each like element in the dictionary you separate with comma, just like a list. And I'll just put 3 here. Also, you should know you don't have to strictly use like integer and then string. Like dictionaries, like you could just use two integers, floats, like all that stuff.
So once again, to grab something from a dictionary, you can just type name of your dictionary and then whatever the key is, and I can put this out. I think that's right. And yeah, you can see this gives us 1 because what Python is saying, or at least what I'm telling Python to do, is just look at my dictionary, look at what value is mapped to 1, which in this case is the string 1. And obviously, if I try and do something like, this, remember this isn't the same thing as index notation for lists. It just happens that our dictionary has keys which are integer values. Like if I wanted, I could even put like text in here and then run it. And as you can see, we have an error because we don't have a key called this gibberish.
Also, yeah, also notice how you can access the first element when you put 1 in here. So like, and that's just like in general, it doesn't go by index. So like you don't count by 0, 1, 2. So if you put this as like 4 and then access the fourth, it won't look for the fourth one. It will just connect to the key, which is just the first element.
Yeah, that's a great point.
Yeah.
Okay, we have another data type. Okay, user input. This one's pretty important. For user input, I honestly, yeah, could you go back to the repl.it? I think it's best if we download it.
Mm.
Okay, so let's say we wanted to have somebody's, I don't know, favorite ice cream opinion, if I can spell opinion. I think that's right. And yeah, let's say I just wanted somebody to enter it. I mean, of course, I could just create a string and then enter whatever value is in here, and then chop. Go away. Yeah, of course, I could just enter it like this, but it'd be better if they could directly interact with the program. So to do that, we're going to invoke another function, which is built into Python, and the parameter we pass in is what's going to show up here in the console. So we enter something like this. So I'm just going to run this and then show what it looks like, and then explain what's happening here again. Then you see we have a little prompt come up here on the right that asks me to enter in my favorite ice cream color, which was exactly what I entered into here as a parameter, as a function. So then I can just type mint chocolate, and then here it prints out mint chocolate. So input just grabs whatever I enter in here and then stores it in this opinion variable for me to use down here. One important thing to note about this input here is that the data type that comes out of an input is always a string. So if I were to run this and I entered like 1 here, so once it reloads here, if I entered in 1 here, it wouldn't be the string 1. No, it wouldn't be the integer 1. This would be the string 1. So then I would have to convert it later if I wanted to do arithmetic with it.
Yeah, and then for converting, you would just use the int method or function.
So you could do the integer up there, right on top of the opinion variable, or you could do it down inside of the print statement.
Mm-hmm. And then we're gonna go into if, else, and elif, like syntax, and then for and while loops. If, elif, and else statements are all conditional statements. So this means they compare like values. Like there's a condition that has to be met, specific condition that has to be met for the code that's inside of it to run. Okay, so here, these statements, this is just an example of what the code that's going to be inside of an if statement. So if condition, and condition has to be a Boolean expression. So we went over Booleans before. It's either true or false. So like if 3 equals 3, that would evaluate to true. It doesn't have to be true. It could also be false. But false just means it won't run. So Oh yeah. Wait. Yeah. So if it is true, then it'll just run whatever's inside of it. And this is just the like generic order, like syntax of these. So it goes if and then elif and else. So if you have these all in like the same like block of code, then they'll run in this exact order. And if you try to put like an else and above an elif statement, then it'll give you an error.
All right, so if statements. I'll just go over it kind of quickly because I noticed that we're kind of running a little bit short on time. But I'm just gonna like go through the entire thing again, and then I'll demo what the code looks like. But for if statements, you can think of it as kind of like just a conversation that you're having with somebody. So an example would be actually not a conversation, just like, okay, pretend you were deciding what you wanted to do for the day. So let's say I created a variable in my code called raining. And what raining would be equal to is a Boolean. And I explained Booleans a little bit earlier, and they can either be true or false. So if I wanted to plan out, say, my entire day, I could type in Python if raining. So I'll just talk about the syntax here. Then just remember what I wrote for raining. If it's raining, then say I want to print rain and umbrella. And this would kind of make sense, right? If it is raining, then I would want to know to bring an umbrella. And if statements are super useful everywhere, you're going to have to write out all of these conditions quite extensively in stuff like games. And yeah, basically whatever goes inside here is a Boolean. So it's that data type we talked about earlier. And whatever code you want to run under this if statement. So like that would be like if this, then something else. So if it's raining, I want to do something. That something that I want to do has to be indented below my if statement. And basically anything that I want to do inside this if statement has to be indented here. So if I wanted to print out like 500 things, I would have to have 500 indents for each line. Okay, and David, can you talk about elifs and else's?
Yeah. Yeah, it is next slide.
I just gave a quick example about what to do. Like I had a Boolean and I said, and that would store whether or not it was raining. And then, yeah, you can handle the other conditions there.
All right, so elif statements, they execute a block of code if a specific condition is met, just like if statements. But instead of having like as many if statements in a row all executing, once one elif statement is true and evaluates, it will just break out of the like block of code. So I got to show an example of this. So if you have like, oh wait, if you have like x equal to 3, and then if x is, let's say, greater than 0, then it will print greater than 0. And then if you also have like if x is less than 10, and that'll print less than 10. So both of these should run because 3 is greater than 0 and 3 is also less than 10. And since there's two if statements, it won't break out of the like block of code. So as you can see, it prints out both. So if we have an elif statement, this means as soon as one is run, it'll break out. So this evaluates to true. So that means this won't even, like it won't even get to the elif statement. So you see there's only greater than 0. And this also goes for a few of like more of these in a row. And this would be like x equals to 3. and if you had this in if statement again. So both of these would run, and this one wouldn't run because the one above it already validated to true. Yeah, you can see it doesn't even get to this one.
Okay, you need me to take over again?
I think I'm good.
Okay.
And then the else statement. If none of the conditions validate to true, then the last statement, which is the else statement, will run. So if we have this and then add an else statement at the end, so the else statement only runs if none of these are true. So if we have, this is like x is greater than 10, x is less than 0, x is not equal to 3, and it doesn't matter if these are elifs or ifs, if none of them validate to true, it will go to the else. So proud none are true. So this is also, you can see just the like syntax of if, elif, and else. And then for loops. So for loops iterate through a given list or range, and at each item the code is run. So let's show an example. Here's an example. So for apple in number list is just a list with the numbers 1 through 7. Every time it goes through, like iterates through an element in this list, it'll run the code that's inside the for loop. So you can see apple plus equals 1. This just means it's incrementing apple. So you see the output is just each one of these values incremented. And also thing you should notice is the variable here, this is a local variable. So you could name it whatever you want because it's only going to be used inside the for loop. So in this case, apple automatically gets assigned to each one of these elements in the list. This also means you can't access apple in like other loops or other things outside the for loop. And then the while loop. The while loop is similar to the for loop in the way that it like iterates through something, but in this case, it'll run its full course until like the statement after the while is false. So once it's no longer true, the loop is broken out of. So in this example, you see while x is greater than or equal to 0, you can see that x starts as 10, and 10 is greater than or equal to 0. And then that means it'll run what's inside the while block. But you can also see that 10 only gets incremented. So it'll go from like 10 to 11 to 12, and it'll never reach, like x would never not be greater than or equal to 0, which means it's an infinite loop. And infinite loops, you don't want infinite loops. You have to make sure you don't accidentally make those. It just, your code will just keep running and it'll never stop. And that's just like, it's not good for your computer.
There's one thing I'd like to clarify. It's just there are certain cases when while loops are necessary, like
Yeah.
infinite while loops, I mean. You'll use them a lot in things like games, which are called game loops. So when you see an infinite while loop, don't like immediately think it's bad. Just think about whether or not it's actually useful for what you're making. I was going to give an example about the Easter egg I made on the website, but that would kind of spoil the fun. But yeah, there are certain cases where it's absolutely necessary, especially in things like animations.
Mhm. Oh yeah. So this is a while loop where it doesn't have an infinite loop. So in this case, it decrements x every time, which means x will slowly go closer to 0. And then once x is 0, because it's when it's not greater than or equal to. So if it's less than 0, then the while loop will stop, and the last number it will print is 0.
As you saw previously, we talked a little bit about functions and how we could use them on certain data types, such as lists. And in this section, we're going to explicitly detail what exactly a function is and how we can make some of our own. And furthermore, we'll look into things called parameters. So this is just the basic syntax of how you would create a function. And remember, as I mentioned previously, a function is just like a tool that you can use. They're little blocks of code that you can recycle for later parts of your project. So to really explain what the syntax looks like, I find it really helpful to think of just this section of your function declaration as analogous to the mathematical definition of a function, which is something like f of x is equal to, let's say, x squared. So the parallel between the mathematics and Python here is that the name of the function here in both these cases would just be f. So you can see here, there are the little parentheses here, and also the input, which is x. In this case, since the input is x to my function f, in Python and also in coding language, this input is called a parameter. So then I'm just going to pretend there's not a second parameter here for a second, and just pretend that we only have x. So then, now we've created a perfect recreation of this mathematical function in Python. To do it, once again, we just have a function named f, and then we just have x. So it's the same thing you see here that you would put into your code. And as you can see here, there's a little extra def keyword here, and that's shorthand for define. Whenever you create a function, you have to explicitly tell Python that you're going to define it using this def keyword. And then after your parameters, put this little colon here so that Python knows that everything under here that's indented is going to be part of the function definition. And what that means is everything that's indented below our defined keyword is basically going to be what that function can do. And going back to our mathematical example, you can see here that in the math that it takes in an input x and gives you x squared, or rather it returns x squared. And to implement that same feature in our actual Python code, we can use this return keyword here and then say return, instead of something, we would say return parameter 1, which is the same thing as x squared. To do squared in Python, or to raise something to the second power, you can have two asterisks right next to each other and then put a 2 at the end. And that tells Python to raise it to the second power. So this definition of our function in Python is the same thing as the mathematical example up here. And then you can draw parallels between there and then create all sorts of functions that you need. And to call your function, you see earlier we created a function to model after the f of x example. If I wanted to use my function that I customly created, what I would have to do is just write the name of my function. So let's say I had a function called ice cream rate, which would most likely give me the ice cream rate at some ice cream parlor. And to call it, I'll just put empty parentheses here at the end, and then this will call the function, which means I'm telling Python I'm going to use it, and it's going to go through all of the code that's indented under this function, run it, and then return me something if it has a return value. So since this is likely going to give me the ice cream rate, I'm expecting it to return the ice cream rate. Also notice the name of the functions here are also, they should also follow camel case or snake case, which we covered previously.
And also you should notice that there's only there's parentheses that don't have anything inside them because the function has no parameters, or when you're calling it at least.
If it has parameters, then you would have to pass in whatever values you had here. So
Yes.
if I wanted to call, let's say I had a function which was called f, if I wanted to call f of x, I would have to pass in some value here. So let's say 2. And since we know that f of x is equal to x squared, then if we pass in 2, we'll just get 4. And it's the same thing in Python. We can call a function exactly the same way and grab its value, assuming that it's returned. So now let's walk to an actual example and see how we can create a function for us to use later on. We'll walk away from the mathematical example that I talked about earlier with f of x and see how we can actually create a different function on our own. It doesn't have to necessarily be limited to mathematics. So as you can see here, I've created a small function called my function. And what I'm going to do in this function is take in two parameters. As you can see here, parameter 1 and parameter 2. Remember, those are just the inputs into my function. And then we'll do some sort of calculation here. Remember, in every function definition, you need this colon here. And everything you want, every piece of code that you want to be a part of this function has to be indented below. So let's say I define a variable in here called stuff, and I take in both of the parameters and cast them to integers. And what that means is just it's a fancy word for convert my parameters into integers. Parameter 2. Okay, so now that I have stuff, now what I want to do is actually use this value, right? As you can see here, repl.it's complaining that I didn't use it. So let me actually use it. So let's just say I want to run some simple logic here with an if-else block. And I run stuff is greater than 0. Remember, I need this colon here again, and then have indents right under here. So remember, so here I'm just checking if stuff is greater than 0, and if it is, I want to set my value equal to true. Otherwise, if stuff is less than 0, I want my value to be false. And then finally, with the else case, which means if none of these two cases are true, I just want to set my value equal to 0. So as you can see here, I have all of these values, but I want to do something with that value, and I want to store it somewhere. So in that case, I can just return value here. And then what will happen is whenever somebody calls this function that I created and passes in the right parameters, I'll get some value out of using this function. So what I can do is I can do something like print my function with the parameters 5 and 10. And like we mentioned earlier, just typing the name of your function with the parentheses and also the parameters that you want to pass in is essentially just using this function and using it as a tool. Remember, a function is just a tool. So then if I run this, what will happen is 5 will become the value of parameter 1, 10 will become the value of parameter 2. When it comes down to this line, line 3, it's going to turn my 5 into an integer, which it already is. But in case somebody entered in a string, it could handle that case. But then stuff is going to be equal to 5 plus 10, because these two are integers. And since 5 plus 10, which is 15, is greater than 0, we're expecting the value to come out to be equal to true. And as you can see, that's exactly what we get. So hopefully this clears up what a function really is and how you can use and create one. Yep, so we already went over this through the repl.it. And over here, we've just once again marked the values through the entire function, starting with the parameters. Okay, so that's really all you need to know to get started with functions in Python. There are definitely a lot more features to them, but it's not really necessary to know all of them just to get a quick start.
And now we're going to move on to importing. So you've already seen a few of the built-in functions in Python, like the int function for converting a string to an integer. And when you want functions that aren't native to Python, such as like generating a random number, you're going to have to import a library. So like for example of random number, when you import, you're getting functions that are already pre-made and you could use them. So you don't actually have to write any functions, you just put the import statement and you could use all the functions built into it. So yeah, not all libraries are natively built into Python, and you can implement their features by importing them. And this is the syntax for importing libraries. It's just import and then the library name. So we're going to briefly go over the random library. So the random module allows you to generate a pseudo random value. And what this means is it's not a truly random number, but like it's random enough for like just normal coding use.
Yeah,
So
and just to add on to him, um, like the way a computer generates a pseudo random value is through a really complicated mathematical function. So what that means is if you knew precisely where you were in that mathematical function, you could basically figure out what the next random value that would be generated by the computer is.
yeah, but you don't have to worry about it because like, you won't be doing any security things. So to generate a random integer from the random module, you have to use the functions that come with this library. So in this example, you would put the library name before the function. So it's random.randint, and these are the parameters. So the randint is just a function that gets a random number between these two parameters. So like in this example, you're printing a random integer between 1 and 100, inclusive. That means it could print 1 or 100, and any of the numbers in between. And we can actually show this real quick. So import random. And also one thing we should go over is if you have like long library names and you use it often, you can shorten it by using the as keyword. So import random as r. So then when you use it, you don't have to type random.randint. You could just type r.randint. And let's just choose 1 in 100, just like for example. So as you can see, it's generating and printing a random number between 1 and 100. And every time you run it, it'll get a new number. So these are just examples of more libraries that we won't go into in this presentation, but these are just useful to know. Like, so Pygame is for making games, NumPy is for math. Similar to Turtle, that just means it's like for drawing, for like making shapes, and then science. So basically, like you just see with these examples just here, there are like thousands of libraries. So there's a lot of things you can do with the import keyword.
All right, thank you all for coming to our workshop. This was just a quick beginning to Python, and hopefully now you'll be equipped to create more complicated projects, such as even machine learning ones. Feel free to check out libraries called, for machine learning, there's a really great library called PyTorch. I think it was on the previous slide. And if you want to look into backend stuff, you could also look into Flask, which is another really popular library. But overall, once again, we just hope that this helps you dip your toe into the water of the vast field of programming. Thank you for coming.